Now I will explain you the function of this code. This code is from the ultrasonic sensor, and well, in this first section we have the setup of the peak as the LCD display, and well, we are using this peak. This is for the library of this peak. This is the fuses. As we can see, we put this fuse, the NowDT, is for deactivate the oscillator from the peak, and so as we deactivate this, we have to use this delay, the delay that we are going to use. And then we have the LCD library and the pins of the ultrasonic sensor. We define pin B0 as the trig and pin B1 as the echo. Then we got this variable that is for the float distance. We're going to storage the value of the distance in this variable. And then we got this void. This is for the measure of the distance. We got the timeout. This is for if the sensor is not detecting something, this variable, this condition will protect the code. Then we got the output low, that is a trig with a delay of 2 milliseconds, and we have, well, the output high with 10. Then we got the delay of the timeout, and then we have this condition, the while. If the while echo is waiting to activate, will not receive a signal, so we put a -1, and this cycle will repeat again and again. If we got the opposite, we got in the echo, we got this value, -1 distance, and well, the distance that we got will be divided by 58, and that value is the real measure.
We have the void main, and the void main is the point of enter of our program. What it means, with the void main we can put these variables, and with these variables we can give this information, this indication, these instructions. And in the main part of our void main we have the configuration of our LCD. Firstly, we have the set trees. The set trees is the direction of pins of the port. In this case, is on the port B, and here we have the information in binary numbers because we are going to use the pins B, and to the LCD, obviously. The LCD unit, what it means. The LCD unit is the initialization of our LCD. In low words, we can say that LCD unit configures the LCD that it works correctly with our program. And finally, on this point, we have the setup timer. And the setup timer is the configuration of the internal clock of the peak. And here we have the indication that the timer 1 is divisible by 2. After that, we have the while true. The while true is a loop that sends indications to the LCD. The LCD, what is going to do? Easily, it is going to print information that is sent by the sensor ultrasonic sensor. Here we have the first information, that is the measure distance. Is the main indication that we want to make the LCD measure the distance or print the measure of the distance. We have LCD Gotoxi 1.1, and it means that this message is going to print on the column first and file first. And here we have the information that is going to be printed. And the LCD Gotoxi 1.2, it's going to be this information, distance in centimeters. It's going to be printed on column first and file 2. And here we have the delay, and the delay is the time that our PLC late to work. In this case, 500 milliseconds. And finally, we finish the program with the classic corchete. Thank you, teacher. That is all for my part.
My name is Jose, and I will present the connections. First, we need to ensure that pins 11 and 32 of the peak are powered with their respective grounds. Next, we have to connect D4 and D7 from the LCD to the respective D4 and D7 pins of the microcontroller, that is this. Once the LCD is powered and the corresponding RS is in this part. RS, RW, and E are connected to the pins D0, D1, and D2. We proceed with the ultrasonic sensor, and this. First, we connect it to voltage and ground in this part and this part. Then the trick pin of the sensors goes to the pin B0 of the microcontroller, and the echo pins goes to the B1 of the microcontroller. That is this part. Right, this part. Well, this is the connection. Next, my partner will explain how it works and how it looks once powered.
Well, the ultrasonic sensor has 4 main pins. VCC, which is to be powered with 5 volts. The third pin sends an ultrasonic pulse with a frequency of 40 kHz. It is at the moment of impact it is returning, and this is where the third echo pin comes in, which is responsible for how long it takes to return in order to have an approximate, and has explained in the code to obtain approximate distance and the GND pin, the which is connected to ground to close the circuit. Well, the three echo pins are connected to the microcontroller, and this with the code that is previously loaded shows an approximate measure of the distance it is located. Now a small demonstration of how it works. As previously explained, our transducer sends a probe to the transmitter upon impact in returns to the transducer or receiver, and this is how it measures an approximate distance at which the sensor is located. Well, we can see a distance approximately of 200 centimeters. Now we can see approximate distance of the sensor is 27 centimeters, 29 centimeters, or approximately 24 centimeters. In this case, we can see the distance, and is